So we want to talk about multimeters. And again, since week one, I've been saying the multimeter is going to be your best friend. If you got nothing out of this semester but knowing how to use your multimeter correctly, I'll be a very happy teacher. Invest in one of those. It's a little bit like the high-end ones, the Fluke multimeters, and they are the HVAC editions. Very good. And we'll talk about these. This is the Fluke 116.
That's the big boy.
Huh?
I said that's a big boy.
Yeah, and that's something you're gonna keep with you the whole time, the best friend, which is a combination between a flashlight and a multimeter. The first line of defense. So we'll talk about the 4 types. So when I ask you about the 4 types of multimeters we have in HVAC, we have this one which is called what? Yeah, what are the names?
Clamp.
Yeah, huh? Clamp on meter? Good name, huh? Clamps. The clamp on meter, and it's the only way to measure amperage. When you measure amperage, you want to measure amperage when the equipment is live. So you're going to clip on this on the wire, not both wires. I'm going to ask you this at least 7 times. Do not clip this on both wires because the reading is going to be 0. Why is it 0? Because they're going to cancel each other. So you're going to take the wire apart and clip it on one. This is going to be the first rookie mistake you do in the field. You go with the clip on mirror and you clip it on the both wires and you get a 0. Hey, it's dead while it's running. No, it's not dead. So you clip it on one of those, either the positive or the negative is actually either the hot or the neutral, and you get the reading. I'm going to have you do this a few times in the lab until you practice very, very well. This is called the clamp on meter, which is for amperage. This is called voltmeter pin, voltmeter detector. So this is something also you can have with you. It's called the voltmeter detector, clamp on meter. And the third one is the multimeter, which does a lot of functions. This does voltage, temperature, capacitor, what else? Diodes, all the other functions that you need. So this is the multimeter, the big guy. This is the thing that's gonna have you built as the clamp on meter, and this is the voltmeter pin. Question, everyone? Huh? 3. 3. So say 3 or 4.
You said 4.
Yeah.
How
did you realize it?
Before showing the digital meter.
No, they're all digital.
Alright,
So
I'll
3.
forget that one.
3 is what we're going to use 3.
Alright.
Okay, sorry. Question? Yeah. Everett, got a question? Oh, okay. So three of them, that's what we have over here. So you need to remember. They have digital and analog. Analog are in the past, nobody uses them anymore. But we're gonna skim over it. But please do not use analog because again, they look nice and cool, but it's really hard to read. Accuracy is not that good, and why would you bother? I mean, these things are very, very reliable and it's easy to read. And they have what's called O2 ranging, so you just put, you don't understand how easy you guys have it. There used to be a time when you have to put the voltage and you have to choose the range and you have to guesstimate the range. That's why you have to know these equations. So you don't put it in the wrong setting and you go and clamp it or like choose the voltage and it burns. You know how many multimeters have burned in my life? A lot. Or you think it's DC or AC, you put it in AC and DC, boom, blows the fuse. So it's very, very annoying. These ones have a lot of electronics. Keith is smiling, he knows what I'm talking about. Like it's really easy to break and sometimes just annoying. These ones, like they are foolproof, really hard to break them. They take a lot of drops and shocks, and they're auto ranging, which means you don't have to worry about the range. And I'll show you some old ones. Probably if you go to Harbor Freight, you'll find old multimeters for like $5.
Really?
With still the range. They'll tell you from this range, click in this, and if you don't, then the fuse will break. You have to change the fuse if it has fuse. Otherwise, just throw it away. I really believe in building things well, having last, not just consume material all the time and waste, making things really not reliable. Again, different school of thoughts. So we'll talk about volt ohm meters. So voltmeter, measure volts, ohm meter, measure ohms, ammeter, these are average. It's just like add meter to anything, and it will tell you what's happening. So we need to use them for diagnosis. Some of them you need to use while the equipment is on. Some of them you need to use while the equipment is off. Which one do you use while the equipment is on? Mostly the ammeter, because it measures the amount of magnetic field around a wire. And in the lab, hopefully you get to use every single function of that. And I'll show you back in the camera. Analog, don't worry about analog. One of the most important functions in a multimeter is continuity. And I used that today actually to diagnose a circuit. Continuity is a derivative function of ohmmeters, which measure the resistance. Let me show you. So if you can remember those symbols, they're very universal in a way. So this little thing, it looks like a wave. It's called, you see the little ohm thing, and this wave. So what it means is, it will measure if the thing is continuous or not. If I put those two together, it makes a noise. That tells you that this thing is continuous. If I want to measure the continuity of this wire to make sure that it's not broken inside, it has complete conductivity from one end to another, I will put that in one end and the other, and it should tell me that it's continuous. So it's good to go through the hot wire with so many connections and just touch for continuity, and the system has to be on or off. What do you think? Huh?
Doesn't matter.
Off
Huh?
or on?
Doesn't matter.
It matters.
Off or
Off.
I took my first shot.
It has to be off, otherwise it might actually do something that's unpleasant. So let's measure the continuity of this light bulb. Let's say we don't know if this light bulb is working or not. I'm gonna go from one end to another and see if it's connected. If this light bulb was burnt, it will not be even. Okay? So it's really fun, and that's why I was saying you should just get a multimeter and start playing with it, and you will find that there's endless functions. If I go with this board and I want to know if components are working or not, I want to test this transformer and see if it's working or not. This transformer here, I can't visually know what's inside, so I'm gonna go and test the leads in the back here. And if it beeps, that means it's functioning. If it doesn't, hear that? And it's giving me a reading too. That's 7 ohms, which correspond to the wires inside the transformer. So this is how I test the transformer for function using continuity. It means the wire is continuous through the entire thing.
How does it pick up the ohms if there's no, nothing going through it? It just.
It's actually sending voltage.
It's.
Good question. It's using Ohm's law. This is Ohm's law in practice. It has a bunch of resistance inside,
Yeah.
and it sends voltage. That's why it has a battery. Has that 12 volt battery, so it sends a small little voltage to try to test it. Let's test this. No. It's broken. Sorry, it's broken. That's a way. And everything has a resistance. You can test the resistance of your eyeball if you want. Don't do that. But let's look at your fingers. No. But things do have a resistance. So there is you can measure the resistance for a lot of things. And they go to resistance here. Last time I did measure the resistance. Yeah. It's the resistance of my thumb. Which makes you think that it's conductive, right? It has a resistance. I did. So it has a resistance. That's why you get shocked. What else you want to test? Okay. You get the idea, right? So this is the resistance. This is continuity. Actually, there was a video of a guy on YouTube who was trying to test the resistance of his tongue or something, and instead of putting on the resistance, he used I think voltage or something, and he zapped himself. It does happen. So, what does this squiggly line mean?
You can zoom in on that one?
There you go.
AC.
Yeah, AC. So you're right. This is millivolt. Millivolt AC and DC. And this is volt AC, volt DC, volt AC. And what is yellow thing? Hertz, which is what? Frequency. What do we expect to see for frequency? Huh? How many?
430.
Let's go. Let's try it out. Oh. 60? Sometimes I get 59, actually 60.01. So we have more frequency. But you should be able to get that frequency. Okay. We have voltage AC, voltage DC. So let's say I goofed off and I put it in voltage DC and I put it in the AC, what will happen? If you did it with the old one, it will blow a fuse. If you do it now, what's gonna happen?
It'll measure it.
See what's happening? It's going very fast between plus or minus. It's going back and forth. So it doesn't give you a good reading. I'm gonna have you go measure batteries and stuff. I wish I have some here, but we'll do it in the lab. Millivolts.
So that one is DC.
Huh?
That last one is
This one is DC. Usually it stays on it too. So they make it really like convenient. So you don't have to like suffer trying to decipher it.
They make it nice and Barney style for us.
Oh, they call it foolproof. Okay, we got that. What about this one? What is this for? Come on, take a guess. We didn't cover it yet, but take a guess. What is this? Yeah, capacitor. So this will measure the capacitors. Before you measure the capacitors, what do?
Discharge it off.
Yeah.
Turn it off. Take off.
Turn off, discharge it. Even if the equipment is off for a few days, probably there's still some charges in it, especially the huge ones. But this one has been off for like a few years, so I'm sure that has nothing in it. So I'm gonna go here and clamp this around the pins. I got 20 microfarad. And actually this one is 20 microfarad. That's pretty good. What about this one here? Huh? Temperature. Can I do that?
Wire.
Can I do that with the leads? No. I need this thing. What is this called? Thermocouple. Did we cover that?
Yeah.
Did
You
we talk
mentioned
about it?
something about it, that you could do the room temperature or something like that.
Yeah. So I'm gonna pass it so you can look at it. This is a thermocouple. It plugs in the lead, and if you look very closely, you see two wires welded together, spot welded.
What's the thermocouple? Which one?
This one.
Last one?
See if you look here, this actually you can make. I spent hours making those. If you want to make those, don't make them using lead. I mean, don't solder them. There's something called spot welder. Has 30,000 volts, and you just touch it, and it should fuse those two metals together. This is the best way to do it to get accurate reading of thermocouples. So, anyways, you can make those, but if you don't have to, don't. You can buy them up. The cable here. Again, what does thermocouples do? In theory, a thermocouple is two wires. One of them is copper, the other one is different wire. And those two different metals, when they're heated, they get hot different. One of them is hotter than the other. Why? Because they are different metals. Being one hotter than the other will generate small little millivoltage. If we can measure that millivoltage, we can transfer that into temperature. It's always consistent. And if you ever stranded in the desert island in the thermocouple, that's what happened. Anyways, if you have to like calibrate it, stick it in ice water, and that will give you what reading. That'll be your what? Your 32 or your 0, and you can stick it in boiling water, and that'll be your 212 or 100 Celsius, and you can fill in the blanks. So if you're applying this in here. Look, it says Fahrenheit. Put that in. Apparently it's the room temperature now. The heat is up. Keep going up. It's just the
You're dead.
huh?
Temperature low.
Let's keep going.
Still dead.
All right, so that's temperature. So we learned about that. This is for micro or nano amperage. That's for small electronic circuit. And if you have very small amperage, you're not going to be able to use a clip-on meter because it's very small. It's not generating enough current, enough magnet around it to be measured. So you will connect your multimeter or ammeter in series with the circuit and measure that little micro amperage. But we're not going to use that. So for us, temperature is good, capacitor is good, continuity is very important, especially if the circuit does not work, you're going to need to use that. Ohms and voltage. So you're going to use this for a while, and if you buy this one, which has most of the common functions you need, probably this will be sufficient. It has a temperature, has capacitor, but this is a very new model. We just got that a month ago. So it has everything you need, very small and concise, AC to DC toggle, backlight, it's pretty good. It has all the functions in addition to amperage. You can set it at amperage, flip it on, and it should tell you what is the amps in AC. So this is for, actually it says HVAC clamp meter. So school should give you one when you graduate.
You should.
We'll lobby for that, don't worry.
Brantford Hall.
You know about the Granger's scholarship, right? If you're in the 2-year program, you can apply for a scholarship and you get $1,500 worth of equipment, worth of tools. Yeah, it's really nice.
Granger?
Yeah, nice. And actually, also, just FYI, don't miss out on all the scholarships they have here in school. Go and ask and fill as many applications as you want. I have students who actually get $5,000 in scholarships. You don't know what you qualify for. First child, second child, this and that. If you live in Chipping, you have 3 legs, you get a scholarship. They have you have different. Seriously, just go and check. Like, what scholarship do I apply for, and be a little bit persistent? And we have sometimes very competent people in school that know everything. You gotta be persuasive and think of what's in there. Be persistent. There's a lot of scholarships here. Okay, so this is multimeters, and this is very simple device. We usually just detect the current or voltage, but it's good to have it in your pocket to touch wires and make sure they're alive before you touch them with your finger. Make sure it doesn't have any.
It works off touch, right? You
Huh?
just touch a wire with it.
Yeah,
Touches it.
even if it's running. So you get something. This is very low voltage, so it must be good. But something that will hurt you, it will be detected, whether it's neutral or hot. Okay, we got that. Key terms: ammeter, analog, whatever, anything with a needle. I'm not gonna spend too much on it because it's obsolete. Clamp-on ammeter, continuity. We know what that means. This is gonna be very important, and mark my word, it's very important. Digital meters, digital has numbers. Magnetic field, we said every wire that has current going through it, 2 things happens to it. It heats up and it creates a magnetic field. Measurable resistance within these these meters are very accurate. They can get some measurement. Ohm meter measures the ohms. Open circuit. What is open circuit? Julio.
It's not a complete system.
This is open circuit. No circuit. Short circuit. There is a path. There is a circuit still, but not the right path. So one of them is short inside, but it's still, there's measurement. And that's why we do this painful thing to know what to expect for resistance. It didn't have to be that much. Voltmeter, that's the voltmeter pin, and the voltmeter measures voltage, and you want to write that. Very important, volts, amps, and ohms. So three of the instrument measures those things using Ohm's law. And back in the days, they used to have an ohm meter by itself, ammeter by itself. That's why you have ammeter, voltmeter, and ohm meter by themselves. So you have you go the bag of stuff to measure. Now you can go with a small thing in your pocket. You know, you're all set. I'm surprised they don't have an app for that. Traveler.
Can't imagine that.
Huh?
I said I can't imagine
Yeah.
going in like a bag just that sees.
Maybe
There's one of those that has like a Bluetooth connection.
Yeah. Yeah. But maybe
you can
what
pull
if
it
they
up
have
from your
these? You
phone.
goes to your phone. You can read the stuff.
Let's make it together, getting rich.
Yeah. Why not? Okay.
Willing to spend time an hour doing research. It's good.
So electrical meters are very common, and again, depending on what you buy and what you purchase, what you use, some of them they tell you how to use the proper one, otherwise it's going to be shorted. If you buy either Klein or Fluke, one of the high-end ones, really there is no possibility of error. Even the $30 one that we have here actually works very well, and even if you put it in ohm meter and measure voltage, it will just give you an error because there's a small processor inside that understands you put it in the wrong place, so it will just trip and will give you an error. So the possibility of fault are becoming less and less than usual than before. So it doesn't matter that much. So in summary about that, to measure resistance you need voltage, right? Let's look at let's put Ohm's law. Just in principle, this is how they work. To measure resistance, you need voltage. So an ohm meter will never run without a battery, because you always need a battery to supply voltage to measure the resistance. So you need voltage with some amps and measure how much amps go through that circuit, and it will give you back the resistance. That's what they're trying to say. And for the ammeter, you need to go and click this on here to measure this circuit. So if you go through those legs, and if you look inside, in between them, there is a complete circuit for magnet that measure the resistance. I mean the amperage going through it. I'll pass it through so you can play with it a little bit. Where did the thermocouple go? Here you go. Get familiar with those. That's this one. And we'll have a chance in the lab to go and experience with most of those functions. Magnetic field, this is how we measure amperage. So in the past, this is how they used the needle to move back and forth for a multimeter. I don't know why it's important to know that, but just for knowledge, I guess. If you have a wire with current going through it, what happens is you have a coil, and with that coil, you have a needle that will move back and forth to show you how much amperage is going through that wire. So if you have one of those old amplifiers, who's doing an amplifier? Josh. One of those old amplifiers with the needles, that's how the needle is moving based on the magnetic field going inside the wire. But nobody uses that anymore, although it does look cool. So again, if we have a three-phase wire, whether you put your clamp on the hot or neutral, you get some reading. But the equipment has to be on. So if you put it on when the equipment is dead or with open circuit, it's not going to give you any reading. A voltmeter, I'm gonna tell you how to measure voltage. So as you saw me do it before, you put the leads on the hot and neutral. What if you put the leads on the hot and ground? What do you think?
Get the difference between what's running through the circuit, what's on going.
Half of it?
Huh?
Half.
That's what you think?
Read it zero.
Huh?
On the ground.
Why is that? Okay, well, let's experiment now. I want to
Right through
experiment.
the ground.
Let me go to this, Jose. I want to show.
Doesn't want it.
So if you put experimentation defies a lot of theory. Could be dangerous sometimes, but still look this way. So I'm gonna put this on voltage AC. And first I'm gonna put it through the hot and neutral. And I got 114. Okay?
Should be the same to ground, shouldn't it?
Almost the same. So what happens is the hot is giving you the power, whether it goes, you complete the circuit going to the ground or complete the circuit going to the neutral, you should get a reading, as long as there is a complete circuit.
I
Huh?
thought you meant like the actual ground.
Ah, no.
Oh my
No,
god.
No, the ground and the.
Yeah.
So when you see an electrician trying to trace voltage, what would they do? They will put the one lead at the neutral coming in, and they keep going, measure the voltage drop throughout the circuit. And I'm gonna ask you to do that. When you do the 3 light bulbs in series, I want you to go measure the voltage drop between neutral. You have to complete the circuit. First light bulb, second light bulb, and third, and you keep increasing the voltage. And this is where you find the most voltage drop. Okay. So this is one way to measure it, and I'm gonna ask you, I think it will be there in the homework with the quiz, what are the 2 ways to measure voltage? Because again, you don't always have access to the neutral. You look at the circuit sometimes, but I'm gonna have to complete the circuit somehow. Sometimes you use the ground, you actually touch the hot and the casing.
Yeah.
If you have a GFCI, it will trip. If you do that in the shop, it will trip because we have GFCI. We will experiment with that. It's kind of cool.
I didn't know that tripped that.
Huh?
I said I didn't know that tripped that.
Yeah, it will trip. If you have GFCI, it will trip.
I mean, I've never had a machine trip on it.
Okay. Yeah. For us, because we have a GFCI, it will trip. But it's good to try to test that. Ohmmeter, they measure, it's good to measure components. We will use that a lot to measure motor windings, to measure the transformer, as I told you, compare resistance with time, decrease or changes, if something inside the transformer gets shorted. So it's very important to know how to measure resistance. Now, continuity, as you see, only tell you if the wire is continuous or not, but does not give you actual resistance. So if the resistance change, that can indicate something is malfunctioning. So, for example, other examples. If we look at this coil here, look at this coil. Look at this coil here. This coil is creating a magnet to pull in those contacts here. So I can test this coil and see if it's functioning or not by testing for the resistance inside here. And usually I can look up the model number and see what resistance I'm supposed to be getting. Because sometimes it will be functioning halfway, like half those coils is burnt or fused together. And if you look very closely, why do you think this is very red? No.
You're talking about the wire?
Yeah.
Why is it red?
Yeah. It's copper, but it's not copper color. It's coated with something, right?
I imagine just to-
Each wire is coated with a small film of tar to make every piece of that coil act independently as its own wire. Why? Because coil, each wire has its own magnet. And if you keep turning, the magnet will be stronger. What if those 2 wires became 1 wire? The magnet is less strong, it's weaker. So if this loses its power, or they all fuse together, or this tar melts, then it loses its resistance, it becomes one wire, magnet is not as strong, it's not going to be able to pull the coil. Does that make sense at all? A little bit? Think about the magnet and the same thing happened with the transformer. This transformer has 60,000 turns in it. If it becomes 50,000, it's gonna give you voltage, but not the same voltage. At least that's what I know. So, another piece of information that I hope you remember. With the clamp on meter, let's say the amperage was very, very small, like 0.001. And you I want a sure number. Is it like really 0.001 or 0.0015? What are you gonna do?
He's in
One trick.
another
Huh?
class. He's in another
Yeah, you did that before?
He showed us that.
Okay, cool. So what you do is, you wrap the coil. Let me show you quickly. So I want to clamp the multimeter. So I'll do 1, 2, whatever you need, 3, and whatever reading I get, you divide by 3. Because you're reading 3 times the magnet. So that's one trick to do if the voltage is, if the amperage is very small, you can wrap it around. Small tricks will create resistance, no resistance, infinite resistance. So back in the days again, the old digital meter will show you infinity. We don't do that anymore. Because why do you think it's infinity from a mathematical point of view? What is infinity? What is this measure? Resistance, right? Resistance is voltage over amperage. So if resistance is voltage over amperage, if this is disconnected, the amperage is 0. It's not going through. So what happens when we divide anything by 0? Infinity. It's like, as the bigger the number, the smaller the number, the more division. So when you divide by 0, you get infinity, and that's why it says infinity is closed. But if you have no resistance, but there's a short, that means there's continuity, but there's no resistance. If it's completely cut, that is infinite resistance, which means a lot. No current. It's based on the math than the multimeter. Comparators, emitter, antenna, batteries. And that's basically the multimeter and how we use them. And these things are better to play with, so you can remember the functions. And again, it's a good investment to have your multimeter with you, so you can try and practice how to use it. Very useful with your car, very useful in your appliances. And when you do your paper, I want you to show me what are the components, what are the resistance, some kind of schematics, how does it work. And you'll find it very helpful. How few students actually who start with fixing stuff at home, just using this little concept. That's really basic electricity. Ohms, amperage, voltage, and power. And I don't know if anybody got the chance to go on the blackboard, discussion board, and like look at the power for few appliances. That'll be like a really nice exercise. You can finish that in like 10 minutes. Just look around you, look at the label, and some of them you don't see the watts, probably you see something else. But yeah, you always have the amperage at least. And finding one of those will help you find the power. Any questions? No questions? We're good? Okay, so we'll stop the video.